Hello everyone, this is Professor Abolghasem Sadeghi-Niaraki from Department of Computer Science and Engineering at Sejong University. I am delighted to welcome you to this focus section on one of most powerful and widely used Python libraries for data visualization, Matplotlib. In the world of data science and artificial intelligence, being able to visualize your data efficiently is just as important as processing it. This is where Matplotlib truly shine. It allows you to turn raw data into compelling visual stories through line plot, bar chart, scatter plot, histogram, and much more. In today's crash course, we'll cover fundamentals of Matplotlib, including both the Pyplot interface object-oriented approach. You will learn how to customize your plot, style your visualize, and integrate chart into your analytics workflows seamlessly. Whether you are analyzing trend, presenting research, or building interactive dashboard, this tutorial will help you master the visualized layer of Python-based data science. So open up your coding environment, as we discussed before, Google Colab, and let's begin creating powerful professional data visualized together using Matplotlib. Please consider all content labeled with TA is based on carefully prepared material, fully scripted and supervised by me, Professor Abolghasem. In many cases, parallel video personally taught by myself also available in this channel, TrueVerse channel. So regardless of presenter, educational content, intellectual property, and video right belong to myself, so please carefully go in detail and practice as much as you can. Thank you very much.
Welcome everyone. Today we are unlocking the power of data visualization with Matplotlib. This incredible Python library transforms raw data into insightful visuals, helping us understand and communicate complex information effectively. So, what exactly is Matplotlib? It's a comprehensive library in Python that allows us to create static, animated, and interactive visualizations. Think of it as bringing MATLAB's powerful plotting capabilities into the Python world. With Matplotlib, we can generate a vast array of charts, whether it's simple line plots or intricate 3D graphs. Matplotlib is built using Python, one of the most popular and user-friendly programming languages today. By leveraging Python's simplicity and the computational power of NumPy, Matplotlib effectively handles large datasets. It integrates seamlessly with other Python libraries, making our data analysis and visualization processes smooth and cohesive. Why did Matplotlib come into existence? Back in 2002, John D. Hunter was working on neurophysiology data analysis and found a lack of quality plotting tools in Python. He wanted something comparable to MATLAB, but open source and accessible. This led to the creation of Matplotlib, filling a critical gap for scientists and engineers moving from MATLAB to Python. Now, let's look at some libraries similar to Matplotlib and how they compare. Seaborn enhances Matplotlib by providing a high-level interface for statistical graphics, making complex plots easier to create. Plotly excels in interactive, web-based visualizations, perfect for dashboards and sharing insights online. Bucket focuses on interactive plots for web applications, handling large and streaming datasets effectively. Despite these options, Matplotlib stands out due to its first, extensive customization. You have granular control over every aspect of your plots. 2. Versatility. It offers a wide range of plot types and styles right out of the box. Foundation role. Many other libraries build upon Matplotlib, ensuring a familiar syntax and compatibility. Community support. A strong user base contributors to continuous improvement and rich resources. Here are some fascinating tidbits about Matplotlib. It's the most widely used plotting library in the Python scientific community. Matplotlib can produce publication quality figures in various formats, including PNG, PDF, and SVG. It supports LaTeX formatting, allowing for professional mathematical notations in your plots. The library is continuously evolving thanks to its vibrant open source community contributing to its development. With the introduction of style sheets in Matplotlib 3, customizing the aesthetics of your plots has become even more straightforward. In conclusion, Matplotlib is more than just a plotting library. It's a critical tool that transforms how we interact with data. By bridging the gap between complex datasets and actionable insights, it empowers us to tell compelling stories through visuals. Whether you're analyzing trends, comparing statistics, or presenting findings, Matplotlib is your go-to resource. Hello everyone, and welcome to the Matplotlib overview lecture. Today, we are going to dive into Matplotlib, one of the most popular data visualization libraries in Python. Matplotlib is often referred to as the grandfather of visualization libraries, and for a good reason. It was created to replicate the powerful plotting capabilities of MATLAB, a programming language often used for numerical computing. If you've worked with MATLAB before, you'll find Matplotlib quite familiar. Before we start, I must say that these hands-on exercises are related to the notebook file for the course Artificial Intelligence and Big Data taught by Professor Abolghasem Sadeghi-Niaraki, Associate Professor in the Department of Computer Science and Engineering at Sejong University. Matplotlib is incredibly versatile, offering the ability to create both 2D and 3D plots. Some of the major advantages of Matplotlib include its flexibility in customizing every element of a figure, the high-quality output it produces, and the wide range of formats it supports. We can also create figures programmatically, which means we can easily reproduce visualizations in different contexts or datasets. Before we begin, feel free to explore the official Matplotlib page at matplotlib.org. Now, let's dive in. To begin using Matplotlib, you'll first need to install it. If you are using Google Colab, like me, there is no need to worry. Matplotlib comes pre-installed, so we are all set. However, if you're working locally on your machine, you can install it using one of these two commands, depending on your setup. If you are using the Conda environment, you can install Matplotlib by running conda install matplotlib. I'm not going to run this one. And for those using pip, you can simply run pip install matplotlib. But since we are in Colab, no installation is required. Okay, now that we've handled installation, let's move forward by importing the necessary modules. Let me remove these. Here we are importing the Pyplot module from the Matplotlib, which provides a MATLAB-like interface for plotting. We are aliasing it as PLT to make it easier to refer to later in the code. Next, for Google Colab or Jupyter Notebooks, we'll use a special command. We say inline. This notebook command ensures that our plots will be rendered directly within the notebook, right below the code cell where the plotting command is executed. If you're using another environment, you'd replace this command with plt.show to pop up the figure in a new window each time you want to display a new plot. Since we are working in Colab, the command matplotlib inline will ensure smooth inline plotting. Okay, let's begin with a very simple example. We are going to use two NumPy arrays and create a basic line plot. First, we need to import NumPy. We'll create an array of equally spaced numbers between 0 and 5, and another array where we square each value from the first array. My first array is a linspace function, linspace, going from 0 to 5. I want 11 numbers, and y is x squared. So here, x is an array of 11 numbers spaced evenly from 0 to 5, and using x double asterisk 2, we generate y, which contains the square of each value in x. So let's take a look at them. This is x, and this is y. Okay, let's move forward with our first plot. We'll use Matplotlib's plot function to create a simple line plot of x against y. Here's the code. Plot, new plot, x against y, and r, which is used for styling our plot and means red. And I give it an x label, and let's give it a y label, and also a title, which is displayed at the top. And I'm going to hit this one. Okay, in this code, we plot x versus y using a red line, denoted by r. We then label the x-axis and y-axis using plt.xlabel and plt.ylabel, respectively. Lastly, we give the plot a title using plot title. And finally, the plot show command renders the plot for us to view. Since we are in Google Colab, the matplotlib inline command takes care of the inline display, so we don't actually need to worry about plt.show here. If I remove this, and if I just type in plot, this command takes care of it for us. Now, let's step it up and create multiple plots on the same canvas. We'll use plot.subplot to create a grid of plots. Here's the syntax. Plot, subplot. Okay, I need one row, two columns. This one is going to be in the first place. And a plot, x against y, red, give it a dashed style. And again, I also want something like this. Now y against x. And a green one that has this style, for example. Okay, so the plot.subplot function divides the canvas into subplots. The arguments 1, 2, and 1 here specify that we are creating a grid with 1 row and 2 columns, and that this plot will occupy the first position. We repeat the process for the second plot. While the procedural method we've used so far is convenient for simple plots, Matplotlib also offers a more object-oriented way to create plots, which gives us more control over the layout and design. Here's how the object-oriented method works. Instead of calling functions directly from PLT, we can create figure objects and axis objects. Then we can call methods on those objects. Let's start by creating an empty figure object. Plot figure. At this point, the figure exists, but it's blank. To add access to this figure, we can use this code. I say figure, add access, and I have to pass in a list. So what this basically means is that when you're adding this access to our figure, start from the initial position from the top left and top bottom of the figure, and these ones, well, this one means 100% of the width, and this one means 100% of the height. So this basically means that this access is actually going to take the entire size of our figure. So at this point, the figure exists, but it's blank. You can add access to this figure like this. I add a new access. I say start from the initial position and take the entire size. And if I hit figure right now, you'll see that it's blank. So this list here basically means that it starts from the initial position from the top left and top bottom of the figure, and these two ones mean that take the entire size of our width and also take the entire size of our height. So now let's plot x versus y on these axes. Sorry. Let's give it an X and Y label. And this is its title. And that's it. Let's display it. Notice how we use methods like setXLabel, setYLabel, and setTitle to add labels and titles to the plot. This approach gives us greater flexibility for custom positioning and adding multiple plots on the same figure. Okay, now let's talk about adding multiple axes to a figure. One of the advantages of the object-oriented approach is that it allows us to add multiple sets of axes to a single figure. Let's see how we can do that. I'm gonna make a new figure, and I'm gonna say axis 1 is figure dot add axis, and this axis is going to take the entire size of our figure. But again, I have another axis, and I'm gonna position it somehow that it's inside the other axis. Okay, so have this much width and 30% of the entire height. Okay, let's see these two. Yep. Here we are adding two sets of x's. xs1, which is the bigger one, and xs2, which is the smaller one located inside the main plot. Let's plot different data on each. xs1 plot x, y, x against y, and this one is going to be blue. Again, on axis 1, let's set it x label, well, 1 x label, and again axis 1, set y label, 1 y label, set title, and we're going to do the same things on axis 2 as well. But this one, I'm going to plot y against x. This one is going to be red. Let's just copy paste from above. So this is going to be 2. And 2 x label, 2 y label, and 2 title. Okay, this doesn't show anything. I have to call figure. Yes, this will give us a large plot with a blue line and an inset plot with a red line. The advantage of this approach is the precise control we have over positioning and layout. Now, let's introduce the plot subplots function, which makes managing multiple plots on the same figure much simpler. Unlike the previous method, when we manually add x's, plot.subplot automatically handles the layout for us. Here's how we create a single plot using plot.subplots. So this method returns two things, both the figure and the axis. This creates a figure and a single axis. Now we can plot on this axis object. I can say plot a red line, set x and y labels, set title, and show me the figure. As you can see, it's quite similar to the object-oriented method, but plot.subplot gives us an easy to manage interface, especially when dealing with multiple subplots. Let's explore how we can handle more than one plot using this function. The real power of plot.subplots shines when you want to create multiple subplots in a grid layout. You can specify the number of rows and columns when creating the subplots, like this. Say figure and axis is plot.subplots. I pass in the number of rows here, and I also pass the number of columns, say 1 row and 2 columns, and show me the figure. So here we've created a figure with 1 row and 2 columns, meaning there are 2 subplots side by side. Now, this axis object is an array containing each subplot's axis. We can loop through this array and plot on each subplot like this. For each axis in our axis, plot x against y. I want my line to be blue. Set x label. Set y label. Set title. And that's it. Give us the figure. So by iterating over the excess array, we can apply settings to all subplots simultaneously. This method is perfect for when you have a uniform layout or when you want to easily control all subplots at once. Now, a common issue when creating multiple subplots is that they can overlap, like this guy here, making it difficult to read the plot labels and titles. Thankfully, Matplotlib provides a simple solution for this, the tight underline layout method. Here's an example where we can create two subplots and apply tight layout. I'm gonna say subplots, number of rows is 1, number of columns is 2 again, and I iterate over them. Plot x against y with g, set x label, x, set y label, and set title. And at the end, what I do, I call the tight layout method on it. So this tight layout method automatically adjusts the positions of the subplots so that all labels, titles, and plots fit neatly on the canvas without overlapping. So here, as you can see, we don't have this problem with our Y. This is a good practice to follow whenever you are dealing with multiple subplots on the same canvas. Next, let's talk about customizing the figure size, aspect ratio, and DPI, which stands for dots per inch. Matplotlib allows us to specify the figure size and resolution when creating it. This can be helpful when you want your plot to be more readable, or when you are preparing them for publication or presentation. Here's how you can set the figure size and DPI. So the figure is plot figure. The fig size can be set by a tuple, and the DPI could basically be any number. I'm gonna pass 100 here. So in this example, fig size equals the tuple 8 and 4 sets the width of the figure to 8 inches and the height of it to 4 inches. Also, the DPI equals 100 specifies the resolution of the figure with more dots per inch, creating a higher quality image. You can also specify these options when using plt.subplots. So if I use the subplots method, here these options can be specified as well. For example, I say give it 12 inches and 3 inches in height, and let's see what it gives us. Yeah, this creates a figure that is 12 inches wide and 3 inches tall. Now let's plot on it. A red line, X label and Y label, now display it. Yeah, these options give you control over the size and quality of your figures, making them more versatile for different use cases, whether for reports, presentations, or detailed analysis. Now that we've created some great plots, what if we want to save them as image files? Matplotlib provides the SaveFig method, which allows us to export our figures in several formats, such as PNG, JPG, SVG, and even PDF. Here's an example of saving a figure as a PNG file. I use a savefig function and I give it a file name .png. This will save the current figure as file name .png. You can also adjust the resolution of the saved figure by specifying the DPI. Here I can say DPI is 200, for example. Increasing the DPI value will produce a higher resolution image. You can also save the figure in other formats, such as JPEG, by changing the file extension. Saving figures allow you to reuse them in presentations, reports, or any other documentation, making this a powerful feature of Matplotlib. Adding titles, axis labels, and legends are essential for making your plots more informative and easier to understand. Let's start by looking at how we can add these elements to a plot using the object-oriented method. We've already seen how to set the x-axis and y-axis labels using the setX label and setY label. Similarly, to add a title to a plot, we use the setTitle method. Now, let's talk about legends. Legends are useful when you are plotting multiple datasets on the same axis and need to distinguish between them. Here's how we can do that. I have a new figure here. Use the object-oriented method. Plot this line against square root of it and plot something else cubed and give it a label x cubed. Yeah, and I hit legend in here. So in this example, the label x squared here and the label x cubed argument provide labels for the two different plots. The x.legend method then adds a legend to the figure, showing which color corresponds to which plot. However, notice how the legend overlaps parts of the plot. We can fix this by specifying where the legend should appear. The look argument allows us to control the position of the legend. For example, here I can say the location is 1. Yeah, as you can see right now, it went on to the top right corner of our image. There are several possible values for look, including 1, which means the upper right corner, 2, upper left corner, 3, lower left corner, 4, lower right corner, and 0 to let Matplotlib decide the best location. Try experimenting with different look values to position the legend where it works best for your plot. Matplotlib gives us a lot of flexibility in customizing the appearance of our plots, including the colors, line widths, and line types. Let's start by looking at how we can set colors in different ways. You can define colors using simple MATLAB-like syntax, such as B for blue and G for green. As we've seen before, let's make subplots. Plot x and x squared. Here I can specify the style, dot and dash, and x cubed here. The style is double dash. I guess it will just show it like this. So here we have our picture, but you must pay attention that MATLAB also allows us to use more specific color names and even RGB hex codes. So here I could say So let's create another figure. I have x plus 1. Its color is blue, which is basically the same as b. And I have x plus 2. This one was x plus 1. Its color, I can assign a hexadecimal RGB value here. For example, 8B008B. This is just random. X plot. X plus 3. The color is some other hexa number. I don't know, like this one. Sorry. So in this example, the color argument lets us choose a color by name or hex code. And there's also something else. Here I can pass in the alpha argument and set it to a number between 0 and 1. So this alpha argument let us control the transparency of our plot. Alright, next, we can also customize the line width and line style to further control how our plots appear. Here's how you can set the line width and style. I'm going to pass in a fixed size of 12 to 6 inches. And let's plot our first plot. X plus 1, color is red. And here I can specify the line width to be this guy. And let's just copy paste this. This one is x plus 2. The color is red again because I want you to see the difference in the line width. And let's make it thicker. Yeah, as you can see, we have two different lines and one of them is certainly way thicker. We can also specify line styles. You can say plot x plus 5, color is green, line width, which can be written like this instead of specifying the full word, and line style is a dash. And I have another plot, color is green again, line width is again 3, and I'm gonna say the line style, not specifying the full word because this can also be abbreviated, dash and dot, and at the end I'm just gonna copy paste this again. We have x plus 7, color is again green, line width, and let's give it another slide, semicolon. Now let's see our figure. You can see different line styles in here. In addition to customizing the line styles, we can add markers to indicate data points. For example, let's plot another line, plus 10, color is blue, and line width is 3 again. Line style is dashes, double dash, and I can set markers. For example, this guy, just a character. Let's copy paste this. Here, we give it another line, color is blue, everything is the same, but we give it another mark. And instead of markers, So if you remember, we were actually making our lines from arrays. So what this marker argument does is that it puts a marker wherever there is a data point in your initial array that you create your plots from. And we can also control the size and color of these markers. For example, let's make another plot in here. Color is purple. I'm gonna choose another custom line width, like 1. Make it dashed and give it a marker. The marker is going to be simple O. And we also need, well, we can specify a few more things, like the marker size can be set to any number, and also marker face color, which I'm going to set as red. Now give me my figure. Yeah, as you can see, this is very beautiful right now. Well, so these options allow you to fully customize the appearance of your lines and markers, making your visualizations as detailed as you need them to be. Finally, let's talk about controlling the ranges of your plot's axes. Sometimes you'll want to zoom in on a specific part of the plot or set custom limits for the x and y axis. You can set the limits for the x and y axis using the set x lim and set y lim. I hit run. Yeah, in this example, the first subplot uses the default axis ranges. The second subplot, however, uses axis tight to automatically fit the axis tightly around the data. And finally, the third subplot uses custom limits for both the x and y axis, zooming in on a specific section of the plot. This control over the axis ranges allows you to focus your visualizations on the most relevant parts. Matplotlib isn't just for line plots. It offers a variety of specialized plot types such as bar plots, histogram, scatter plots, and box plots. While Seaborn, which we'll discuss later, is often more user-friendly for statistical visualizations, it's still important to know how to create these basic plots in Matplotlib. So let's start with the simple scatter plots. Plot.scatter x and y. So a scatter plot is great for visualizing relationships between two variables. Here we are plotting the x values against the y values, which creates a scatter of points showing how x relates to y. Next, let's create a histogram. A histogram helps us visualize the distribution of our data. So let's make a sample. I need a random sample, and I use sample function for it. From 1 to 1,000, give 100, and display it as a histogram. So the hist function automatically bins the data into intervals and then plots the frequency of data points within those bins. This is an excellent way to understand the distribution of a dataset. In this case, we generated random numbers between 1 and 1,000 and plotted their distribution. Another useful plot type is the box plot, which is great for summarizing distributions and identifying outliers. So I'm gonna say my data is random This is a way of creating beautiful lists. What I'm basically doing here, I'm actually calling this function on each element in this loop and returning the entire result as a list. And then I say box plot, data, I want it to be vertical, and we must pass this one too. So this box plot shows the distribution of 3 datasets, each with a different standard deviation. The central line represents the median and the boxes represent the interquartile range. The whiskers extend to show the range of the data, and any points outside of that range are considered outliers. Box plots are especially helpful when you want to compare distributions between multiple datasets. As you've seen, Matplotlib is a very versatile and powerful library. However, the examples we've covered just scratch the surface of its capabilities. If you want to dive deeper into Matplotlib and explore more advanced functionality, I recommend checking out some additional resources. First, the official Matplotlib project webpage. This is the main hub for all things related to Matplotlib, including the latest updates and documentation. Second, the source code repository. If you're curious about how Matplotlib works under the hood or want to contribute, this is the place to go. Third, the Matplotlib gallery. This is one of the best places to get inspiration and see examples of the wide variety of plots you can create using Matplotlib. Then, the Loria tutorial. This is a great tutorial for learning more advanced topics in Matplotlib. And finally, another excellent Matplotlib reference with detailed examples and explanations. By exploring these resources, you'll be able to refine your plotting skills and gain insights into the more advanced features of Matplotlib. There's a lot to learn, but with practice, you'll become highly proficient in creating visually compelling and informative plots. Okay, in this notebook, we covered the essentials of Matplotlib. We started with simple line plots and then explored various plotting methods, including subplots, figure customization, legends, and specialized plots like scatter plots, histograms, and box plots. We also learned how to adjust axis limits, save figures, and customize plot appearances with colors, line size, and markers. While Matplotlib offers extensive control over plot appearance, it can sometimes require more effort for complex visualizations. That's where Seaborn, a more advanced statistical plotting library, comes in handy. In upcoming lessons, we'll dive into Seaborn and see how it builds on top of Matplotlib to make more intricate statistical plots easier to generate. For now, practice using Matplotlib by experimenting with the plots and methods we've covered today. Try customizing the plots, changing the figure sizes, adding legends, and saving your work. The more you practice, the more intuitive it will become. If you have any questions, feel free to refer back to this notebook, explore the documentation, or reach out with your queries. Happy plotting, everyone!